So like we just started this toward the end, so let me just recap what we covered. So we did a notice and wonder, which is not on your paper. It's just something we talked about, but a lot of important skills were revisited in this. So one thing you noticed probably was that the means were all the same, which you could easily tell the means even if it wasn't written there for you because all the data is symmetric, which means the mean matches the median, and you could see that wherever could draw my line of symmetry is going to be my mean as well, because they're all symmetric. Then you saw that even though they all have the same mean, they all have different MADs and standard deviation. Why? What does MAD and standard deviation tell us about a data set? The variability, which in simple terms means how spread out it is. So that's why, like, your mean could be one number. It could even be like a really high number depending on the data set. But your standard deviation in MAD could be low numbers. It just depends. Tells you different things about the data. So mean and median tell you typical values in the data set. Standard deviation and MAD tell you how spread out it is. So that's why, like, the one in the bottom right corner has a standard deviation and MAD of 0 because it's not spread out at all. So good test questions would be like, if I added a point to this data set, how does that change the MAD and standard deviation? Well, without doing the math, you could say, like, is it making it more or less spread out? And things like that. So things that are more spread out, you would expect to have a high or low standard deviation. The more spread out it is, the higher or lower the standard deviation is. Higher. So more spread out, higher standard deviation or MAD. That's why the one that's not spread out at all was 0. Okay, so keep that in mind. You don't always have to put it in the calculator to know that the standard deviation will change. And that's what we're trying to train you to figure out. We also covered these questions yesterday, which were on your paper. So again, it doesn't matter what the numbers are. Standard deviation just tells us how spread out it is. So if they're spread out by the same amount, they will have the same standard deviation. That could save you time on the test if you notice that. Like, hey, they're each spread out by 1, then the standard deviations will match. Hey, this one's more spread out than that one. This one should have a higher standard deviation, and so on. So next thing we're going to look at, and probably the only thing we'll look at on this paper, is this cool down with the histograms. They love to put histograms on your tests because you can't put the histogram data in your calculator. So that's where you actually have to know, like, hey, standard deviation is most spread out, like which one should it be yourself. So you can't put that into there. So for this one, you have 3 different histograms all representing majors that people graduated with. And here's some descriptions for each. So like the mean salary of 100 recent college graduates who majored in engineering was about 63,000 with a standard deviation of about 10,000. The mean salary of 100 recent college graduates who majored in business was 52,000 with a standard deviation of around 19,000. The mean salary of 100 recent college graduates who majored in the social sciences was about 45,000 with a standard deviation of about 6,700. So you're matching based on these descriptions which major goes with which histogram. Okay, so do that briefly. Make your matches. I'll assign a reporter in like a minute or two, and we'll share why you made that match. Reporter is, tell me one match that you were able to make. Okay, so let's see. Let's evaluate that. engineering majors, that was this first bullet point. Their mean salary was about 64,000. Do you guys agree? Does that graph have a mean of potentially around that much? How do you know where to look for the mean? Okay, toward the middle, because mean is a measure of center. Now, median is the center exactly, and obviously this isn't like very symmetric, so like you can't really see what the median is gonna be to match the median. But we know the mean should never be like the lowest point. The mean should never be the highest point. It should be something in the middle. Or near the middle. It is a measure of center. So yeah, are any of the other histograms centered around about 64? So this is in tens of thousands. So that's a good sign. Another thing to compare, like if there was another one that was around the 64,000, compare the standard deviations. What does standard deviation tell us about data? How spread out it is. So compare the three different standard deviations. So engineering was 10,000, another one was 19,000, and another one was about 7,000. Does this one look like it's the second most spread out compared to the others? Okay, so then we could confidently say with those two considerations, graph 2 is the engineering major. And if you did your homework yesterday, that's what you should have figured out. You should have figured out what you need to compare in order to answer those questions. Like, am I comparing the means for a typical value? Or am I comparing the standard deviations for a variability question? All right, table 1, whoever my reporter is, tell me another match that we're able to make. Oh, you mean like of these bullet points? So you mean 150 business? Well, I was just. Okay, so the histograms are labeled with numbers. And then here's your options for what they could be represented. Oh, I was looking at there's. Okay. Which would tell me a match. So we already matched the engineering. What was engineering? We think one is business? Yeah. Okay. So let's take a look. So the business majors, they are this bullet point. So they're the ones with the 52,000 mean salary. Do you guys think that this one's centered around 52? Do you think this other one is centered around 52? Yeah. Okay, so let's keep comparing. The business majors had the highest standard deviation. So what does that mean? Should it be the most spread out or least spread out? Most spread out. Do you think graph 1 is the most spread out? No. So actually the business majors should be the third histogram, this one. And you need to use both to figure out why it's that fast. So it's the most spread out. And if you were estimating where the mean probably is, this is like toward the middle. All right. So then that means graph 1 should be the social sciences, who had the smallest standard deviation, which could be good because that means they make consistent income, like whatever it is they're getting, what they think they could get. And is it centered around the 45,000, you guys think? Yeah. Yeah. Now for the others, like the business, why do you think that this major is more spread out? Like in the real world. Why do some business majors make around 25,000 and others make around 90,000? What could possibly lead to that? So this is the learning target where you attach it to the real world. Yes. Okay, so not everyone that majors in business goes after the same jobs. So like people that major in education, they all probably primarily go get teaching jobs. Like there's not a whole lot you can do with an education degree outside of that field. There is possibilities, but with business majors especially, maybe some of them are opening businesses, maybe some of them are just managing a business. Maybe some of them have a successful business and maybe some of them don't. All right, it's variable. So that's why that one might look like that. And then we know engineers tend to make a higher income. Theirs is more centered on the higher end of the scale and things like that. So be able to attach it and see why is it like that as well, or what it could mean about the situation. All right, questions on this exercise? All right, I think that's all we have to do from this note sheet. So we're gonna go to the next one. But before we do that, let's just decompress with some general announcements. So today's lesson 15, and let me picture, okay. Today's lesson 15 is comparing statistics for data sets. And measures of center, measures of variability will be looked at again. And it's going to be the last lesson of this unit. So after today, you'll have learned everything you need to know. And you can start this weekend preparing for your unit test, which will be Thursday next week. We also have those quiz on Monday, but quizzes I should hope are not very stressful. They're only 10 points. It's a checkpoint before you get to the unit test, so use it for what it is. Notes on quizzes. You cannot use notes on unit tests though, so it's just a checkpoint to see how you're doing. Then I'm recording right now. I generally always record in this class, so I'll always put that right here where it says today's lesson. But the one from last year is there too, just in case you're working ahead or something like that. The practice will be in Schoology. It'll match the same title you see here. And I talked about this at length yesterday, so I don't want to talk too much about it again today, but you do have your binder check on Tuesday. It's going to be your first project grade, so please start off strong. There's always at least one person that shows up to school on binder check day and says, oh, I don't have it. Like, okay, and then I put it missing, and it's hit or miss whether they ever do show it to me again. I certainly don't ask for it again because it's not my responsibility. Oh yeah, so I asked for it the day of binder check day. It's your responsibility to have it. Otherwise, I just put the missing in, and then you have like until a certain amount of time to resubmit it if you didn't get full points. But you should have it ready by the time you walk in on Tuesday. You either have the notes or you don't, and you recreate them if you don't. Like it's very easy to get 100% in that. And how much is a project category worth? 20%. So for first semester, we have enough binder checks that that's going to be the only thing in that category. So not taking notes will dramatically hurt your grade. Like, think about it. If you don't take any notes, so you have a 0% in that 20% category, the highest grade you'd be able to get is an 80%, and that's if you miss nothing on it. Don't miss any questions on your homework. You don't miss anything on the test. You don't miss anything on your final exam. So realistically, if you don't do well on your binder checks, the highest grade you could get is like C. So keep that in mind. Very important. Everything is in there from the start of the semester, so you can watch the videos and catch up. Get these notes. There's also the papers right here you can grab. Take notes on your own. The study guides are available. Please, like I try to tell you, focus on what's going on right here, right now. Like, obviously, you should do your daily practice for whatever we covered that day. But if you have a lot from a few weeks ago that are missing, don't like worry about them as much right now. Worry about these primarily. One, there are a lot of points. And two, they'll help you prepare for the unit test. That is also a lot of points. And then you have these extra credit things that can help make up for some of those missings and again, help with your unit tests. So really focus on what's going on right here, right now. If you happen to be at a point where you can go back that far and work on things, go ahead. But I made this list of what you should do in order of priority and where you can find everything too, because I know you're still figuring it out. Test corrections and completing all other missing work is the lowest priority. Okay, everything else is higher priority. So use that what you will, but everything else will help you way more to be prepared for the test. Everything that's highlighted is everything that's for the following week. So Monday we have a quiz, Tuesday minor check, Wednesday is the deadline for late work, Thursday is your major test. So pretty important week. Any questions on anything of them? So now this week is really ready for next week. All right, so new note sheet, the one you picked up today. You are going to look at the histogram and the statistics for 4 different people. And this is representing the bowling scores for the last 25 games played by each person. You're going to choose 2 people to join your bowling team and be prepared to explain why. So compare their statistics, compare their shapes. Who would you pick to people from this group for your bowling team and why? Okay, table 2, same reporter that I assigned before. Table 2, tell me one person you'd pick to have on your bowling team and why. Okay, so you want them to have a large ranking scores? Okay. Because it would still think they would more consistent. Okay, so high variability would technically be less consistent. So, I mean, when you compare, so I put some lines around our measures of variability. And it kind of just depends what you think we should look at. So standard deviation looks at all of the data. Interquartile range only looks at the middle 50%. So like if the data is skewed, we might only consider the middle 50%. So if we just look at the standard deviations, theirs is not the highest, but it's also not the lowest. It's like the second lowest. So from that, we could say generally more consistent. It's just the way you said it, or was a little. Like you said, it was very spread out. Compared to the others, it's generally consistent. It's the second highest, or sorry, the second lowest standard deviation. So if they're generally consistent, we might want them on our team. Table 3, someone other than person A. Okay, so maybe person B because they're the most consistent. And again, they have both the smallest standard deviation and the smallest IQ odds. So that could be a reason. Did anyone pick person C? Okay, I'm kind of surprised. Oh, yes, why did we pick person C? Okay. The reason why I said I'm surprised not many people chose person C is because when you're comparing the statistics, person C has the highest mean and median, which means what about them? They score higher on average. So you could say person C because they tend to score higher. Granted, I would actually say theirs is more spread out compared to the others. Like it takes up more of the number line. And the statistics are a little higher too. There's a spread. So they tend to score higher, but there is a lot of variability. So maybe that's why people didn't choose that person. It just depends what you want for your team. All of these are a matter of opinion. But there are some things that you say that can be wrong. Like if you said person C tends to score the lowest, well, that's not true according to this. You might be able to say there's touches the left side of the number line more, but so do some of the others. All right, anyone pick person D? Can anyone give me a reason someone might pick person D? Yes. Okay, so because of this, they tend to score lower. However, occasionally, and on more than one occasion, if you read the y-axis, they tend to have some perfect games. So even though they tend to score lower, they do have some perfect games. So maybe you might want that on your team. Nobody else had a perfect game or was even like this close on it. So it just depends what you want. And you need to be able to know what to compare. So measures of center tell you typical values. Measures of variability tell you how consistent, how spread out. So questions on this activity. Again, it's a matter of opinion. It depends what you want. But that was practicing what's compare. All right, we're gonna go to this activity next. So all of the marathon runners from each of two different age groups have their finishing times represented in the dot plot. So this is a great example of what's on your test. Sit up and look. I think people stand up and take their notes, so like we can do that too. This is an example of what's on your test where it's not really feasible to put it in a calculator. You can't even see all the individual data points. Some of them are clustered together because they're so close. So that's where you really have to know what each statistic means. So that way you could answer these questions correctly. So the questions are, which age group tends to take longer to run the marathon? And which age group has more variable finish time? So think about it, respond to it. I'm gonna have you vote in like a minute. Based on these dot plots, answer these two questions. Okay, so close your eyes. Raise your hand if you think the 30 to 39-year-olds tended to take longer. Raise your hand if you think the 40 to 49-year-olds tended to take longer. Okay, you can put your hands down. And you can open your eyes to see the answer. 40 to 49-year-olds is correct. When they say tend to take longer, what should we be comparing? Like tends to. Are they asking about center or variability? center, because typical values, what they tend to take, like that's basically asking for mean, average, median, that's what they mean. All right, so what you should have done was estimate either the mean or median, usually both are toward the middle. So like if I had to estimate it for the 30 to 39-year-olds, visually it looks like the middle would be somewhere around here. For the 40 to 49-year-olds, visually the middle looks like here. Right? And these happen to be aligned with each other, like they're the same number lines. We know that to the right on the number line, the numbers get bigger or smaller. Bigger. So just visually comparing, you could see, or you could like estimate the numbers. The 40 to 49-year-olds tend to take more minutes than the 30 to 39-year-olds. Right? Questions on that? Some of you on the quiz, or even on your homework, where it says who tends to be the fastest, remember faster means less time. Okay, so just keep that in mind. But the 40 to 49-year-olds, and you should have compared like the means and medians. All right, we're gonna vote for the second one. So think of your answer for which age group has more variable finishing times. All right, close your eyes. Put your hand up if you think the 30 to 39-year-olds had more variable finishing times. Put your hand up if you think the 40 to 49-year-olds had more variable finishing times. All right, you can put your hands down and open your eyes. The 40 to 49-year-olds had more variable finishing times. Because variability is asking what in simple terms? How spread out it is. And without me putting it into the calculator, visually I can see this one looks more spread out. There's more gaps in the data. And also it's taking up more space on the number line itself. If you couldn't tell, like if it was close to you, one measurement you could compare that is a measure of variability is the range. How do you find range? Like normal range? Good. So if it was close and you couldn't really tell, you might want to compare the ranges. So it looks like this maximum was like about 380, the minimum being about 235. This maximum looks like about 450, and the minimum looks like about 250. This math I could do in my head. I think this one is 125, but I'll double check. Okay, yeah, I'm pretty confident 145. The bigger range has more variability. I wouldn't normally compare ranges unless it was like close. So that's something else you could look at too. Questions on that? All right. So last activity on this note sheet, and when we go over it, it should be pretty fast because you'll hopefully be experts by it by now. But you have all these different groupings. So it starts on the front and it ends on the back. But for each group, you are going to determine the best measure of center and the best measure of variability to use based on the shape. So like for each individual one. Then you're going to determine which one has the greatest measure of center and which one has the greatest measure of variability. So when I say, what's the best measure of center, what are your options? What are my options for measures of center? See, this is why we're still doing this, even though it's repetitive, and I think you should know it by now. You can't tell me what an example is for a measure of center? Median is a measure of center. And mean. So when I ask you, what's a better measure of center? Don't say standard deviation. That's not a measure of center. Don't say bell shapes. That's not a measure of center. Okay. Measures of variability. What are some examples of measures of variability? Range. Okay, good. Yes, range is also a measure of variability, but for these, those are your options to pick from. IQR or standard deviation / map. So that's one step. For each individual one, I'm going to ask you what's the better measure of center and what's the better measure of variability. Then I'll ask you between these two, A or B, which one has the greatest measure of center? Which one has the greater mean or movement? Then I'll ask you which one has the greatest IQR or standard deviation / map, whatever. Okay? Questions on what we're doing? All right, I'll start by giving you like 5 to 7 minutes to just answer it yourself. When we go over it, it should be pretty fast because most of them are 50-50 options. Hoping you shouldn't have to guess or anyone have to tell you the answer because it's something like covered a lot. So look at your notes if you need to from prior days. But we're going to start going over them in about 5 to 7 minutes. Okay, so I'm going to call on you individually. And again, like this is supposed to be like lightning round going over it. No more of the like sitting and staring, trying to really figure it out. Like it's a 50-50 chance. You either know it or you don't. And hopefully you're learning something from other people's answers because it's very repetitive. Okay. Let's see. Austin. For 1A, what is the best measure of center? No. So when I ask you what's the best measure of center, these are your options. Mean, lucky guess, or do you know why? Okay. So class, why do we choose the mean for this data distribution? Because it's symmetric. When it's symmetric, we always prefer the mean. You guys know what it means for something to be symmetric? It means you can draw a line somewhere and it be a mirror image on both sides. Okay, so that's why we prefer the mean. Jacqueline, for 1A, do we prefer the IQR or the standard deviation / map? Okay, good. Whether that was lucky yes or not, who knows? But it is correct. Anytime we prefer the mean per center, we prefer the standard deviation / map for variability. Darian, for 1B, do we prefer the mean or the median per center? What'd you think? Good. Because it's a metric. Make sure we're sitting up and looking. Make sure the hunching over, like sit up. Isn't elementary school anymore. I'm not your mom. Everyone needs to sit up. Like you writing. Like sit up. That means back touching the back of your chair. Okay. All right, Micah, for 1B, what is the best measure of variability? And okay, good. Because they're very similar. The test could say one or the other. Now for each group, so for group 1, we need to say which one, A or B, has the highest measure of center. Isaiah, for group 1, which one has the highest measure of center? What do you know what the measures of center are for both? Okay, you should be able to. You should be able to tell me the mean because the mean for VDS is -10. Good, so which is higher? Would you rather owe someone $8 or $10? So that is why 1A has the greatest measure of center. I'm gonna abbreviate that with like this arrow. So higher mean. So that is the measure of center. Now, Peyton, does A or B have a higher standard deviation / MAD? Actually, no. 1A has the higher standard deviation / MAD. And you technically don't need a calculator for that, but you could have put it in the calculator and compare the numbers, which is higher. This one is technically more spread out because all the data is away from the mean. And it's like peaked on the very ends of the data. All the data in 1B is clustered around the mean. So 1A is more spread out. That one has higher variability. Question. Okay. So then Jace, for 2A, do we prefer the mean or the median? The mean because why, class? 2A is symmetric. I can draw a line of symmetry down where the 20 is, and it's a mirror image. Blake, do we prefer the standard deviation / MAD or IQR for 2A? Like nobody should have to guess. Nobody should have to be told the answer. Oh, I didn't hear you. Sorry. Did anyone else hear? Okay, sorry, I didn't. So me standing there, probably should have done it again. But standard deviation / MAD for variability. For 2B, Riley, what do we prefer for the best measure of center? Mean. The class is 2B symmetrics. Okay. Let's see. Jonathan, for 2B, what do we prefer for variability? And standard. Okay, good. Same meaning as in MAD. D is for deviation. So variability, how far something is. Okay, for this group, for group 2, Ricky, which one has the greatest measure of center? For group 2. B is correct. What is the mean for B, class? 30. That's where I could draw my line of symmetry. Where I drew my line of symmetry for A was 20. So yes, 2B has a higher mean. Brianna, which one has a higher standard deviation / MAD? Because A is more spread out. Good. For 2B, it's like over just a few numbers, like 6 different numbers. This one's over 10 different numbers. Okay, so 2B is less spread out. Therefore, 2A has the higher standard deviation / MAD. All right, Dexter, 3A, do we prefer the mean or the median? The median, because this is our first example that is not symmetric. Good, it's not symmetric. Therefore, the mean will not match the median. Let's see, Josiah, what do we prefer for variability in that one? IQR. Colton, for 2 or 3B, do we prefer the mean or the median? The median. Jacqueline, do we prefer the IQR or MAD / standard deviation? IQR. Again, it's not symmetric. And for this group, Madison, which one would have the higher median? Incorrect. Now, I didn't actually find the median, but look at where all this data is clustered in 3A and look at where it's clustered in 3B. My median for 3B is going to be like around the 1 and the 2, I would assume. I haven't done the math, but it's going to be around here because the data is all shifted to the left. The median for 3A is going to be around maybe 7, 8, maybe even higher. So you could actually do the math because it's a dot plot and you can compare like in the calculator if you need to. But 3A will have the higher median. So the data shifted more to the right. The middle is more to the right. Let's see, Darian, which one will have the higher IQR? A, because the middle 50% does look more spread out. And again, you could actually do the math and justify your answer further. All right, that's all we have time to review. But the answers to the rest are in Schoology. I highly encourage you to check them. They're really great test type tests up there. Any questions right now?